In this video, we will discuss integrated silicon linear sensors. Let's first do a quick review of temperature sensor characteristics. An ideal temperature sensor is accurate, repeatable, low cost, easy to calibrate, and has a fast response over a wide temperature range. Furthermore, a simple relationship between sensor output and temperature is highly desirable. Integrated silicon linear sensors exhibit some of these characteristics. This is an integrated silicon linear sensor. You may have encountered this sensor in a previous course or lab, so you may already have experience in using it. As you can see in this picture, an integrated silicon linear sensor is a 3-terminal device. The terminals on the left and right sides of the device are for power input and ground, respectively. It is very important to read the datasheet for your silicon linear sensor, since you want to ensure that you are using the correct terminals for power and ground. Getting these terminals mixed up could ruin your temperature sensor. The center terminal is for the sensor output. Integrated silicon linear sensors output a voltage, which you can measure with a device such as a multimeter or an oscilloscope. Integrated silicon linear sensors are relatively low in cost. An MCP 9701 temperature sensor can be purchased for 26 cents on the DigiKey Electronics website. What's great about these temperature sensors is that they have circuitry that does the linearization and signal conditioning. Therefore, integrated silicon linear sensors produce an output voltage that is linearly dependent on temperature. This is shown in these graphs of temperature versus output voltage. For example, an MCP 9701 sensor will output a voltage of 0.9 volts at 25 degrees Celsius, 1.9 volts at 75 degrees Celsius, and 2.9 volts at 125 degrees Celsius. That's an increase of 1 volt per temperature increase of 50 degrees. That's very convenient. The datasheet for an integrated silicon linear sensor typically shows a sensor transfer function, such as the one shown here. Knowledge of the temperature coefficient T sub C and the sensor output voltage at 0 degrees Celsius will enable a relatively easy determination of ambient temperature from a measurement of sensor output voltage. Integrated silicon linear sensors are relatively low in cost, simple to use, and produce an output voltage that can easily be measured and converted to temperature. However, these sensors have a number of disadvantages when compared to other temperature measurement devices. These sensors are less accurate, operate over a narrower temperature range, and are less responsive. So, here is a summary of the temperature sensors that we have discussed, which thus far is only the integrated silicon linear sensor. Cost, ease of use, and a linear output are advantages of this sensor. However, its responsiveness in stirred oil is relatively long. It's not as accurate as the other sensors that we will be discussing, and its operating temperature range is narrower than other sensors. Let's take a quiz. Assume that you are using an MCP 9701 temperature sensor. At a certain temperature, its output is 0.9 volts. Convert this voltage to temperature using the equation shown here. Assume that the sensor's output voltage at 0 degrees Celsius is 400 millivolts, and its temperature coefficient is 19.5 millivolts per degree Celsius. Please pause the video, work on this problem, choose an answer, and unpause the video to see the correct answer. The correct answer is 25.64 degrees Celsius. This is a relatively straightforward calculation, which is one of the main advantages of integrated silicon linear sensors.